today the topic for discussion is function. So the definition of function is what? Let x and y be two sets, in the two sets. Then the subset R of x cross y such that for each x belongs to x, there is a unique y in y with xy belongs to R is called a function from x to y. So what is the function? Function is the subset of x cross y. What is the function? Function is the subset of x cross y. We know that if what is x cross y? If x contains suppose 3 elements and y contains suppose 4 elements, then x cross y contains 3 into 4, that is 12 elements, and that are the order pairs. This is the set x cross y is the set of order pairs. Okay. So when the subset of x cross y is called a function, if for each x in x there is a unique y in y such that x y belongs to R, that is x is related to y, or the image of x is y under this function R. So under this relation R, and then this relation is called a function. That is a function is also called mapping or map. The function, the another word for function is what? Map or mapping. So when we say the relation is function, if this condition is satisfied, that is for each x in x, there is a unique y in y. There are two conditions, that is each condition and unique condition. If these two conditions are satisfied, then we say the relation is function. So these are some examples of functions and not functions. So the first example, the set A instead of x, take A, and the B, y instead of y, we take B, and this F is the function from A to B, and the not function, it is the relation from A to B. So how we can define this relation? That under this relation, 1 is related to A. Under this relation, 2 is related to 2 elements C and D. 3 is related to B, and 4 is related to C under this relation. Then this relation is not function. Why is not function? Because the condition, unique condition fails in this example. That is this 2 is related to 2 elements. What are that? 2 related to C as well as D. And that's why this relation is not function. It's just relation from A to B. It is not function because this unique condition fails in this. When the relation is called function, if each element of x, capital X, that is in this example, if each element of A related to someone, so the condition each is satisfied in this example. Each element of the A related to someone, for example, 1 related to someone, 2 also related to someone, 3 related to someone, 4 related to someone, and therefore this each condition is satisfied in this example. That is, each element of this A, capital A, related to someone, but related to what? Not to unique elements. This one is related to only one element A. That is this for 1, this unique condition is satisfied. 3 element related to only one element B. 4 related to only one element C. So for the element 1, 3, and 4, this unique condition is satisfied. But for 2, the unique condition fails because 2 related to 2 elements, not 2 unique elements. Unique means 1 and only 1. But 2 is related to 2 elements, and therefore this is just relation from A to B. It is not function. This F is not function. So what is the reason that F is not function? Because F of 2, that is 2 related to 2 elements. And how we can show the 2 related to D? We say F in bracket, round bracket, 2 is equal to D. Means under F, the function, the element 2 related to D. Under the relation F, 2 related to D. Now we can write F of 2 is equal to D. And we say that the image of 2 is D. If we write this fx is equal to d, means image of 2 is d, or the d has 2 as pre-image. What is the pre-image of d? Is 2. What is the image of 1 under this f? Relation f is a. That is f of 1 is a. But f of 2 is what? D as well as c. And therefore 2 related to 2 elements. And therefore this unique condition fails in this example, in this relation. And therefore it is just relation. It is not function. So if we observe this example, then here the unique condition is satisfied. Here is the set W to X, this relation H denoted by H, and under this relation, B is related to 3, that is only one element. C is related to 2, that is only one element. D is related to 4, that is only one element. That is the unique condition is satisfied in this relation. That is, but each condition fails in this example, in this relation, because this A is not related to any element of this X. That is, A is not related, and so each condition is failed. When the relation is called function, if each element of X, that is each element of this set, is related to unique element of this set. But here the condition, each condition fails. Here the unique condition fails. In this example, each condition fails because each element related to someone, but here A is the element in this W, which is not related to any element from this set X, and therefore each condition fails. So when the relation is called function, if the two conditions are satisfied. First, it is subset of X cross Y, and each element of X related to unique element of Y. Then we say xy belongs to R means what? Xy belongs to R means X is related to Y. Then the relation is called function. So in this first example, the unique condition fails, and in the second example, this example, each condition fails. If we observe the third example, then it is denoted by G, relation G from X to Y. And X contains 5 elements, A, B, C, D. X contains 5 elements, and all elements are related to someone. So each condition is true in this example. And if we observe A, what is A related to what? Only one element 2. What is the image of B? Or B is related to only one element 2. C, if you observe C related to 3, D related to 3. That is C related to only one element 3, D related to only one element 3, E also related to only one 2, 4, and therefore each and unique, all the conditions are satisfied, both the conditions are satisfied in this relation, and therefore G is the function. That A related to only one element, B related to only one element, C related to only one element, D related to only one element, also E related to only one element or unique element. And therefore each element of X related to unique element of Y, and therefore the relation, this relation is a function. So when the relation is not function, if some element of this say X not related to unique element, or each element of this W not related to some element of this X, and therefore this function is, this relation is not function, this relation is not function. In this condition, in this relation, F, each unique condition fails, and in the relation H, each condition fails. But in this example G, both the conditions, that each and unique, both conditions are satisfied, and therefore G is a function, because each element of X related to unique element of Y. So this situation is not allowed in the function, that one element related to 2 elements. But this condition is allowed. This situation is allowed, that 2 elements related to same element. This A and B both related to 2. This C and D related, both related to same element. But this is allowed in the function. What is Not allowed in the function that one element related to two elements. This is not allowed in the function, but two elements related to unique element, only one element, same element. This is allowed in the function. That is a function. This G is a function. Okay. So under this G, A related to 2. How can show under G A related to 2? That is right. G in round bracket A is equal to 2. What is its meaning? G A is equal to 2 means under the function G, A is related to 2. Or we say that image of A under G is 2. What is the meaning? That is image of A is 2 under the function G. Or A is related to 2. Or we can also write this in round bracket A comma 2 like this. A comma 2 belongs to G, small g. Okay, means image of A is 2 or pre-image of 2 is A. We say that pre-image of 2 is A. Image of A is 2 and pre-image of 2 is A. GB is equal to 2, right? GB is equal to 2 means what? Image of B is 2 under G. Like GC is equal to 3 means what? Image of C under G is 3. GD is equal to 3 means image of D is 3 and image of E is 4. So this is the relation. We can also write this relation in the form of order pairs as a subset of X cross Y. So what is it? We can also write G in this form in the set form, set of order pairs. What is the set? Contains the element A2. What is the meaning of A2? Means A is related to 2 under G or GA is equal to 2. GA is equal to 2. So we can write GA is equal to 2 in this fashion. A comma 2, B comma 2, C3 and D comma 3, C comma E comma 4, E comma 4. That is the order pair E4. Okay. So this relation, you can denote the relation by using this notation, either write their images or by using diagram or by using set. So we can represent the function in three fashions, that is in three ways. That is either diagram or a right image of each element or a right the set of order pairs as a subset of X cross Y. So these are the three types to express the function. That is either diagram or the write the image of each element or write the set of order pair in the form of set of order pairs. So here is another example of function. So X is the set contains these elements 1, 2, 3, 4, 6, 12, 6 elements, and this set Y contains the 4 elements 1, 2, 4, and 8. And under this function, under this relation, 1 is related to 1, 2 is related to 2, 3 is related to 1, 4 is related to 4, 6 is related to 2, and 12 is related to 4. And this is the function. This is the function because each element of this X related to unique element. If you observe, 1 related to only one element, 2 related to only one element, and therefore each element related to unique element of Y, and therefore this is the function. Example of function. Then note, take X and Y as above. That is this is the X and this is the Y. And consider this S as 1, 2, 2, 4, 12. Then S is not mapping or S is not function from X to Y. Why S is not function? Because each element of X is not associated or not related with unique element of Y, unique element in Y. Okay, each condition is fine because X contains total 6 elements 1, 2, 3, 4, 6, 12, but only 3 elements, 1 related to 2, 2 related to 4, and 12 related to 8. That is these 3, 4, and 6 has no images, are not related to any element from Y, and therefore here, for example, 3, 4, 6 in X are not associated with any element in Y, and therefore this S is not a function. It is just relation. It is not function. So then another example, S1 is what? 1, 2, 1, 4, 2, 1, 3, 2, 4, 8, 6, 2, 6, 1. That is therefore each element 1, 2, 3, 4, 6 and 12 all are related. That is each condition fails, each condition true in this example S1, but unique condition fails. 1 related to 2 as well as 4 under this relation S1, and therefore S1 is not mapping, or S1 is not function, because under this 1 belongs to X is not associated with unique element, as 1 associated with what? 1 corresponds to both 2 and 4. 1 related to 2 as well as 4, that is not related to unique element, and therefore S1 is not mapping, or S1 is not function. So here this S is not function because each condition fails. This S1 is not function because unique condition fails. Each element related. Each element of X related, but not unique element to unique element, and therefore this S1 is not a function or not mapping. Function is also called map or mapping. So this S1 is not mapping. It is just relation from X to Y. Here is the function defined in the form of formula. What is the function? Defined as fx is equal to x square, and f is function from R to R. That is the set x and y instead of x and y. Both the sets x and y are denoted by capital R. That is set of real numbers, and this set contains infinitely many elements. This capital R contains infinitely many elements, and under this relation fx, fx is equal to x square means what? If we take f of 2, then what is f of 2 is 4, 2 square 4, means 2 is related to 4 under this function. What is f of 3 is 9, 3 square is 9, that is 3 is related to element 9, and if you take 4, then 4 related to 16 under this relation, because also minus 4, if you find f of minus 4, then minus 4 square is again 16, that is under this relation 4 is related to 16, minus 4 is also related to 16. So this is the function from R to R, and we cannot show it is diagrammatically because this set R, capital R, contains infinitely many elements, but we find image of each element of this capital R, and this is the another way to denote the function. The functions are denoted by here formula. Here the functions is denoted by, in the previous example, if we observe this example, the function is denoted by diagram. The function is denoted by this function G is denoted by the formula, that is the right image of each element. Also the G is denoted by the order pairs, set of order pairs. Okay, so these are the 3 ways. Also we can denote the function by using formula, that fx is equal to x square. Some functions are denoted by formula. Fx is equal to x square is the formula for this function, and R to R. You can find the image of each element under this function. Okay, under this definition. So these are some ways to denote the functions. Here is the example that A is the set ABCD and B is the set ABC. Define the function from A to B by using this formula, that f of A is B, f of B is C, and f of C is C. And then f of B is, and f of D is B. Then f is a function. Why is function? Because both conditions, each and unique, are satisfied for this. That is, each element ABCD, all these ABCD elements of A, all are related to someone, and all are related. And if you observe A, then it is related to only one element. If you observe B, it is related to only one element, unique element, and therefore this f is a function. Next example is again the set X is contains the 4 elements ABCD, Y contains X, Y, Z, 3 elements, and the relation is defined by using this diagram. That is A related to X, that is unique element. Every element of this set X related to someone, and each element of this X related to unique element. If you observe A related to only one element Y. If you observe B related to only one element X. C related to only one element. D related to only one element, and therefore this relation A to B shown in this diagram is a function, is function. When the relation is not function, we know that when the relation is not function, either each condition fails or unique condition fails. Why this relation is not function? Because two related to two elements. And why this H is not a function? Because this A is not related to any element of this X. That is, each condition fails in this example. Here, the unique condition fails, and that's why these two are not functions. Only they are relations. While if you observe this diagram, then both the conditions, each and unique, are satisfied in this diagram in by this relation, and therefore this relation is a function. Here is the example that f is function defined by using the formula that fx is equal to 3x minus 4. And the question is find f of 1 by 3 and f of a plus a. So how you can find f of 1 by 3? Just replace x by 1 by 3. 3 into 1 by 3 minus 4. That is, answer is minus 3. That is, the image of 1 by 3 is minus 3. And the image of a plus h, f of a plus h is what? 3 in bracket a plus h minus 4. That is 3a plus 3h minus 4. This is the image of a plus h. So these are some examples of functions and not functions. So in the next lecture, we will see the image and range and domain, codomain of the function.